Welcome back. My name is Tracy, and this is part 2 of a tutorial on how to convert a single-player AR game into a multiplayer game using the ConjureKit SDK by Aoki Labs. In part 1, we went through project setup, ConjureKit implementation, and using the Vikia module to broadcast messages about the game state and spawner position to all participants in the shared AR session. If you missed part 1, there should be a link in the top right corner. If you prefer to skip part 1, you can check out this specific commit from GitHub, Game State Notification Implementation, which will be today's starting point. If you do that, just remember to paste your app key and app secret into the start method of main.cs. Like before, the link to this tutorial on the documentation site is in the description below, so please open that as we'll be copying some code from it. Today we'll be focusing on how to use the Entity Component System, or ECS, to sync the hostiles, which are the ghosts and pumpkins in our little game here, the player scores, and visual effects. For more information about the ECS, we have a short tutorial about it linked here. In short, an entity is an identifiable object, for example a player or a hostile. A component represents some data attached to the entity, for example a hostile's lifetime or a player's score. And a system is a process that operates on components. We'll use systems to do things like handle hits on hostiles and update participant scores. Let's start by creating a new subdirectory under scripts called systems. Add a new C# script and name it hostile system. And paste in this base implementation code. Note that the hostile system inherits from system base, which is a class provided by the ConjureKit for implementing systems. When deriving from system base, we need to override 3 methods: getComponentTypeNames, update, and delete. GetComponentTypeNames tells the system which components it should listen to, update gets notifications when components are added or updated, and delete gets notifications when components are deleted. In getComponentTypeNames, we'll return a string array containing the names of the component types, hostile component, and hitfx component. In addition to using these string identifiers to register components, we also want to cache the uint of the component's representation. The uint is an unsigned integer that serves as a unique numeric identifier for each component type, hostile component and hitfx component. To do this, we'll define a method called getComponentsTypeID that's called after successful registration of the system. Next, we'll add methods for adding and spawning hostiles, and of course also one for deleting and destroying them. The addHostile function attaches hostile behavior to an entity. It takes an entity, its speed, and the ID of a target as inputs, and creates a payload containing data about speed, the target's position, a timestamp, and the type of the hostile. It also adds components related to the hostile entity. Delete hostile is pretty straightforward. It just deletes the hostile component. We do want to be able to add and update components without passing any payload, for example when we add a hitfx component to the hostile here, so we'll define an empty byte array object. Next, we'll create a method called syncHitFX, which will invoke the hitfx and broadcast it. So now we have methods for adding and deleting hostiles and syncing hitfx. The next step is to implement the listener, which is where the other 2 override methods come in. In these, we'll loop through the updated and deleted arguments in the respective method. These arguments are of type EntityComponent bool. EntityComponent is an object that holds the type ID of the component, the entity ID, and the payload. The bool value indicates whether the entity component we're currently iterating on belongs to an entity we've created, and based on this bool value we can apply different logic. So here in update, we'll loop through the collection and spawn the hostile with the payload from each entity component in the collection. You'll see here that how a component is handled depends on whether it's a hostile component or a hitfx component. If it's a hostile component, the method constructs the spawnData object and triggers the spawning of a hostile entity. If it's a hitfx component and the payload contains data, it invokes the hitEffects. If the payload doesn't contain data, for example when we initialize the hitfx component, it doesn't play the hitEffects. We do it like this because the update method gets called whenever there's an add component or update component event. We've invoked some actions here, invoke spawn hostile and invoke hitfx, but we haven't actually declared them, so let's do that now. And we'll need one for invoke destroy hostile too. For the delete override method, we just need to call invoke destroy hostile. That's it for the hostile system class. Let's go back to main.cs and initialize the system. First, we add a field for hostile system. Then we initialize it in the onJoin method, and register the system with session.registerSystem, which takes as its second argument an action to invoke hostile system.getComponentsTypeID, which caches the component type IDs. We also want to clear hostile system when the user is disconnected, so we'll set it to null in the onLeft method. Before we can test the system, we still need to make some adjustments to hostilecontroller.cs. Add the auki.conjurkit namespace, a session field, and a hostile system field. And add ConjureKit to the initialize method. When a user joins a session, we'll cache the session, and when the user leaves, we'll set that cache to null. Next, we'll create methods to listen to the events from hostileSystem.cs. We need both setListener and removeListener. Down here in spawn hostile instance, we want to replace total spawn count with the entity ID, and remove the line that increments total spawn count, since this value used to identify each hostile entity in the initial single-player mode. We'll also pass the syncHitFX method as an action here. Previously in setListener and removeListener, we invoked destroyHostileListener and syncHitFX, which haven't been implemented yet, so let's do that now. We also need to change a few things in hostilescript.cs. Add the action onHit to the initialize method. The spawnHitFX method doesn't exist here yet, so we'll add that in. And let's not forget the ConjureKit shooter.models namespace. With these updates, the hit effect should be synced across all participants in the session. We also need to broadcast the add hostile event to all participants, so let's go back to hostilecontroller.cs. In the update method, we'll remove these lines about hostile spawning and use hostile system to spawn the hostiles instead. Note that main.getRandomParticipantEntityID hasn't been declared yet. This function just gets the entity ID of a random participant so that participant can be set as the target of the newly spawned hostile. Let's go back to main.cs and declare it. Of course, a prerequisite to getting a random participant's entity ID is having a list of all the participants, so let's create that. And in order to update the participants' entities in the session, we'll declare an update participants entity method. This method loops through all the participants' entities and checks if it has the flag called entity flag participant entity. If so, it adds that entity to the participant entities collection we just declared. Update participants entity will be called from game start, and on entity deleted. If there are fewer than 2 participants left, the game will be over. Now let's get the random participant's entity ID. Note here that we need to explicitly type the namespace for the random class because we're using both the Unity engine and the system namespaces, and both contain a class called random. Back up here in onJoined, we'll call hostileController.setListener, and in onLeft, we'll call hostileController.removeListener. And in the start method, we'll update the hostileController.initialize method, since it's using ConjureKit now. Lastly, in order to broadcast hostile destroyed events, all we need to do is go back to hostileController.cs and add a line to invoke remove hostile instance. Oops, looks like I missed a semicolon here. Now let's build and test the game again. At this point, the ghosts and pumpkins as well as the hit effects on them are synced across both devices, but the scores aren't. The last stage of the upgrade to multiplayer is syncing participant scores and the visual effects displayed when shots are fired. Naturally, we'll implement another system for this, which we'll create a new C# script for and call participant system. This one behaves very similarly to the hostile system, so we don't have to go through it again in as much detail. The main thing to note is that the two components we're managing with the participant system are the score component and the shoot FX component. And just like we had to make some adjustments to hostile controller before, we'll go to participants controller now and modify it. First we'll use the namespaces alki.conjurkit and conjurkitshooter.ui. Then add these new fields. Just as we had set listener and remove listener in the hostile controller, we'll need them here in participants controller too. There's already a set listener method, but we can remove this and pass our new participant system to it so that all participants can listen for score changes using the system and components. And since we've called the method showParticipantShootLine above, we'll need to declare it now. Now we need an initialize method which will initialize all the needed fields in this controller. It also sets up event handlers for ConjureKit. When ConjureKit joins a session, it initializes the session, and when ConjureKit disconnects from a session, it clears the score cache and destroys game objects related to participant components. Next, we want to implement a way to get all previous components from the participant system, which is useful when a new participant joins and needs to be synced with the session. In this case, the new user should see all the scores components. Upon joining, we'll also spawn some necessary game objects, so let's update onParticipantJoins to do that. If a participant is already in the participant components collection, it updates their name UI. If not, it creates new line render and name sign elements for them and adds them to participant components. Additionally, it initializes the participant's score and score cache. To update the player's score displays, we'll modify the onParticipantScores method. This just ensures the participant's current scores and names are correct. And whenever a player leaves the session, we should remove all the components associated with that player. Let's do this with a method called onParticipantLeft. Of course, we also need methods to handle updating the participant scoreboards. Here you can see that in Update Scoreboard Position, we find the scoreboard game object in the participant components collection and reposition that game object with an offset of 60 centimeters on the y-axis so it appears above the player. And it's rotated to be facing the camera. The Update Participant Scoreboard method loops through the participant components collection, and for each entity it passes the entity ID, entity position, and camera position to update scoreboard position to update each participant's scoreboard position. And we call Update Participant Scoreboard in the update method so that the scoreboards will get updated in every frame and thus follow their players. That's it for the scoreboard. Now let's work on the effects when players fire shots. A shoot line is fired from the tip of the wand in the direction the camera is pointing in, so we'll call it the participant shoot line and create a coroutine method for it. Coroutines are functions that let you pause their execution and resume them in a later frame, so they're useful for animations like the shoot line that need to span several frames without blocking the rest of the game's execution. System.collections is needed for coroutines, so add that up here. showParticipantShootLine will start the coroutine, and of course we'll define the coroutine itself as well. Whenever the invoke shootFX callback in the participant system gets invoked, showParticipantShootLine will receive the shoot data, and with that data it will start the showShootLine coroutine. The shoot line will be shown for 200 milliseconds. The last thing we need to implement in participants_controller.cs is a way to reset the score, so let's create a new method for it called restart. And here it sets everyone's score back to 0. We don't want to clear the score cache anymore when we're getting the score entries because this is called from game over, and we still need to display the scores after the game ends. Now let's go back to main.cs and fix the initialization of participants controller. In the start method, replace setListener with initialize. We also need to initialize the participant system, so let's first add a field for it. Now we'll update the onJoin method. First we register the participant system. Then we subscribe update participants entity to the onParticipant scores event. And call the setListener method. Next, we'll create an overload method for update participants entity that takes an unsigned integer and score data as arguments. We don't do anything with these, but they're needed in order to be able to subscribe the method to the onParticipant scores event callback in the participant system. This allows us to update the remaining participants entities if there are changes in the session, for example if a player leaves. Now in the onLeft method, let's add some lines to call participants_controller.removeListener, unsubscribe update participants entity from the onParticipant scores event, clear the participant entities, and set the session to null. We also need to clear the spawn gun. In onEntityDeleted, let's call participants_controller.onParticipantLeft. We also want to reset all scores whenever the game restarts, so in the GameStart method we'll call participants_controller.restart. Now let's go to gunscript.cs. In the start method we can remove initialize. As always, declare a new field to reference participant system. And update the initialize method. Remember when we updated the onLeft method in main.cs previously, we cleared the spawn gun. That method doesn't exist yet, so let's create it now. In showShootLine, we want to sync it across all participants with a call to sync shootFX. Now let's go back to main.cs. And add a field to hold the current user's device entity. Then update the onParticipantEntityCreated method so it caches the user's device entity, initializes the gun, and broadcasts the addition of the participant components. In shootLogic, we'll call the updateParticipantScore component method. That's pretty much it for the game mechanics. The last thing we need to do is add a reconnect mechanism for when a participant gets disconnected from the session. We'll do this inside the onStateChange method. So if the state is disconnected, we'll connect again. I'm getting an error here. Apparently I have showParticipantShootLine twice, so I'll delete this one. And it looks like these two methods are outside of the participant's controller class for some reason, so I'll move them up. And I have a little bit more debugging to do in gunscript.cs. There's a typo here, and the initialize method needs to be public. Okay, we should be good now. Since we changed participants controller.cs, let's drag these prefabs into their correct fields. That's it. Now the game is completed, and we can build and test it. Using the entity component system, we've synced the hostiles and participant scores, plus all the effects related to shooting the hostiles, so that multiple people can play the game together. You can use similar logic to convert your own existing AR games into multiplayer, which we think is a pretty cool thing that the ConjureKit enables. Hopefully this tutorial has helped, and thanks so much for following along. If you need more guidance or just want to show us what you're building, please join our Discord server. We'd love to have you around.